Okay, so number 2, we can see that this is a parabola that opens down, so it's going to have a maximum height to it, and the maximum height is at its vertex. So we can use our negative b over 2a formula to find this vertex. So negative 8 over 2 times negative 2 be negative 8 over negative 4, which is 2. Okay, and when you take that 2 and plug it in here, you get a y of 3. So it says what is the maximum y value? Maximum y value is the 3. Number 8, we want to solve this equation. 1/4 x squared plus x equals 1. Okay, now you can use different methods. Completing the square, quadratic formula, different things. I'm going to use completing the square, I think. So I'm going to multiply everything by 4. So if I get multiply by 4 here, I get x squared plus 4x equals 4. Okay, now complete the square. Half of 4 is 2, 2 squared is 4, so I'm going to add 4 to both sides. This factors to be x plus 2 quantity squared equals 8. Undo the squaring by square rooting it, equals plus or minus the square root of 8. The square root of 8, if you break it down, is 4 times 2. The square root of 4 is 2. And the square root of 2 does not simplify. And I can take this 2 and subtract it over. So negative 2 plus or minus that. Okay, so there's my answer for 8. Number 9. Okay, for a rectangle parking area shown at the top of the next column, each equation says, which equation says the area is 40,000 square yards. Okay, so we want the area. So how do I find area? I take this times this. So area is this times this equals 40,000. So A. Number 10. The mat around the picture shown measures inches across, which equation says that the area of the picture itself is 800. Okay, so the picture itself. So how do I figure the picture? So the picture, okay, it's got a 1 inch, an x-inch frame. So it would be 21 minus x minus x. Okay, so one dimension of the picture would be 21 minus 2x. Okay, the other dimension is 34 inches minus x and minus x, so minus 2x. So the picture itself would be 34 minus 2x times 21 minus 2x equals an area of 600. So number 10 is B. Okay, number 11. Okay, I'll put 11 over here. Suppose that x represents one of two positive numbers whose sum is 30. Represent the other of the two numbers in terms of x. Okay, so if one of the numbers is x, then the other number, okay, if they have to add up to be, the sum is 30, the other one has to be 30 minus the first number, right? Okay, so that's your first number and your second number. Part B, what are the restrictions on x? Okay, well, this number, it's going to have to be greater than 0 because it says two positive numbers, so it has to be greater than 0. And, okay, actually just 0 is not positive, so greater than 0. Also, what's the biggest it could be? Okay, well, if they have to add to be, if two numbers have to add to be 30, I know it's going to have to be less than 30 then. Part C, we want the product of the two numbers. So if these are my two numbers, my function would be, I'll just use f of x, whatever we use there for that. The product would be this times this. So it would be 30x minus x squared. And D, determine analytically and support graphically the two such numbers whose product is a maximum, okay, maximum there. So what you want to do is we're going to solve this. So where is that equal to 0? Okay, I like to do this. I'm going to do this by factoring. So I'm going to get x squared to be positive. So I'm going to just take the x squared over here, subtract your 30x. Okay, and if I factor out an x, I have x minus 30 left. Okay, and I get x equals 0 and x equals 30. I'm sorry, that's when I'm solving it. I don't want to solve it. I want to find the maximum value, don't I? Okay, so the maximum value occurs at the vertex, right? So to find the vertex, negative b over 2a. 30 divided by 2 is 15. Okay, so if one number is 15, the other number, 30 minus 15, would also be 15. So my maximum area is going to occur at 15, 15. Okay, yep. And then the maximum product is going to be 15 times 15. Yeah, we use P for product. The maximum product is going to be 15 times 15, which is 225. Okay. Number 14. A homeowner has 80 feet of fencing. Move this over yet. 80 feet of fencing to enclose a rectangular garden. Okay, so we have a garden here. I want it to be a rectangle. What dimensions give the maximum area? Okay, well, if this side's going to be x, this side's going to have to be x, right? And there's 80 feet of fencing. So basically it's going to have to be, I know I have prior knowledge. The more you can get to be more of a square you're going to get, okay? But 80, so if you think about it in half, this would be 40, right? So this would be 40 minus x. Yeah, and then this would also be 40 minus x, okay? So our maximum area, okay, area is going to be this times this. So I take this times 40 minus x, gives me 40x minus x squared. And I want to know where the vertex is, so negative b over 2 times a gives me 20. So if one side's 20, 40 minus 20 would be 20. So if it's a 20 by 20, the perimeter would be 80, right? Okay. And you have your maximum area there. Number 15. Okay. America River College has plans to construct a rectangular parking lot on land borrowed on one side of a highway. There are 640 feet of fencing available to fence the other 3 sides. So we got 3 sides. Let x represent the length of the 2 parallel sides. Okay, so this is kind of like when we did in our notes. Okay, we have a highway here. And then we have our fence around these other 2 sides. So this is x and this is x. Now, I know there are only 640 feet. So this would be 640 feet minus this side and this side, so minus 2 x's. Okay, so part A, the remaining side, that's what we just did there. Part A is 640 minus 2x. B, what are the restrictions on x? Okay, x. It can't have a negative distance here, so it has to be greater than 0. And if these were both, if you take half of 640, it's 320. It'd be 320 and 320, and there'd be nothing left for this side, right? So it has to be less than 320. Okay, the area would be length times width. So I'll put it in terms with this. Area is equal to our length times our width, which equals 640x minus 2x squared. Okay, and then part D. Okay, it asks you to put it in a graphing window, so you can change that in Desmos too. determine graphically the values that will give you an area between 30,000 and 40,000. So when you graph this, you can use Desmos. And basically your graph, I don't know, looks something like this. But where is it between 30,000 and 40,000? So you want to find these x's here corresponding to those. Okay, so in Desmos, those would be 57.04, and the other one is 85.17. Okay, so this will correspond to 3,000 feet. That'll correspond to the 40,000 feet, so it has to be between there. Okay. Oh, actually, if we look at, let me do that one over. If you do it on Desmos, I think you're going to get a little bit different graph than I displayed there. I think you're going to get a graph, I don't know, it looks something like this. So at 30,000 feet, let's say that's 30,000, and at 40,000 feet. It's going to happen at two places. Oh, it's negative. Teachers can mess up on this too. Okay, so at 30,000 feet and at 40,000 feet, okay, is the area. So we want to know the x's for those. So this one here and this one here would have, that's where it's between 30,000 and 40,000. And those came up to be the numbers that I had out there first. 57.04, I'll just say 57, and 85. Okay, around those numbers. Now it also happens over here. So between this number and this number. Okay, and those were at 234.8, so almost 35, and 263, almost 263. So between those two distances and those two distances, it's above 30 and 40,000. Part E, maximum area. We want to know the vertex. Okay, the vertex of this would be the negative b over 2 times the a. Okay, and 640 divided by 4 gives you 160. And then, so at 160, right, this would be my vertex at x is 160, and the y of it, okay, you got to take that 160 and plug it in here, and you'd get 320. No. You get 51,200. So that's the maximum area they can get for parking, 51,200 feet squared. Okay, so it actually asks us for the dimensions. This would be 160. This here would be, plug in the 160 and figure that out, it'd be 320. Okay, so that's number 15. A little bit harder there. Number 16. Okay, a farmer wishes to enclose a rectangular region bordering a river with a fence as shown in the diagram. So we got our river, and we want to have a fence there. And we want to have 3 different areas. Okay, 3 fences coming out to create 2 areas here. Okay, she has 600 feet of fencing. Okay, so this distance here would be 600 feet minus 3 x's in this case. Okay, so part A asks us the length of the remaining piece would be 600 minus 3x. Part B, a function that gives you the total area. Okay, my area is going to be the length times the width. which gives you 600x minus 3x squared. Okay, so there's gives me my quadratic. Part C, what dimensions would give you an area of 22,500? So 22,500 is equal to this. Okay, and you can solve this different ways. Let's say you use Desmos. Okay, so if I bring everything over here, I'll get a graph that looks like this. And I get two different answers here. So if I do that, I'll explain that more. If I get 3x squared minus 600x plus 22,500. And if I graph it, I'm on Desmos. That's the easiest way to solve. Okay, I'm just going to use that this time. You could use quadratic formula or anything else too. But you get these 2 points. You get x equals 50, and you get x equals 150. Okay, so that is where those 2 points is when we're going to get this area here. Okay, if we want the dimensions, okay, the other side, this would be 50 by 50 times 3 would be 150. That minus 150 would be 450, so be this times that. And if this is 150 times 3 would be 450, that minus 450 is 150. So if I have a 150 by 150, or if I have 50 by 450, both of those give me that area that is needed there. Okay, and D, maximum area. Once again, I want to find the vertex, right? So that negative B over 2 times our A, 6 be 100. And when I plug that 100 in there, okay, for the area, it'd be 100 squared. Okay, and it gives me 30,000. Okay, so that right there is the maximum area that we can get in here when each of these sides is 100, and this length here would be 600 minus 300, which would be 300. It gives the total fencing. Okay, number 18. Okay, they get a little bit easier here now. Okay, golf ball is hit, so it has a height of this. Okay, part A. Okay, if you remember our formula the other day, this is the velocity, right? It's being hit at 60 whatever, and this is the gravitational pull. That's a constant. Okay, so what's the initial height of the ball? Our initial height, remember, is at the end here, so 0 feet. Okay, it's being hit off the ground. How high is the ball after 1.5 seconds? So our height at 1.5 seconds would equal negative 16 times 1.5 squared plus 60 times 1.5, which gives us 54 feet. And the maximum height is the vertex. So we're going to use the negative b over 2a. So negative 60 over 2 times negative 16 gives you 1.875. So that says after 1.875 seconds, okay, to find the actual height of it then, we're going to take this and plug it in there, and it comes up to be 56.25 feet. Okay, so that gives you your maximum then. Okay, next problem is number 21. Okay, cardboard is twice as long as it is wide. Drawing a picture always helps. So if the length is this, we'll call this 2x because it's twice as long. It is made into a box with the open. We're cutting 2-inch squares off of each side here, so 2 inches by 2 inches. We're cutting these corners out. Okay, so after those corners are cut out, we then have these sides that can be folded up. And what's the height of that side? 2 inches, right? Okay. Okay, so there's the setup. So here are the questions. Okay, the length of the original piece of cardboard, so we said our length was 2x. Dimensions of the bottom of the box, okay, so this right here would be the bottom of the box. Okay, so this distance here, the whole thing is 2x, and I got to subtract 2 and 2, so 4. So it would be 2x minus 4 would be one dimension. And then this distance is x. I got to subtract 2 and 2, right? So this distance here would be x minus 4. Okay. And the restrictions on x, x has to be greater than 0. Actually, it has to be more than just 0 because it has to be greater than 4, right? Okay, because if I have 2 and 2 for the sides of the box, I need something in between there, right? So it has to be greater than 4. Okay, part C, the volume. So I'll call that V of x is equal to our length times our width times our height. The height of the box was 2 inches. Okay, and if you multiply this all together, distribute everything through, you'll get 4x squared minus 24x plus 32. Part D. Okay, we want a volume that will be 320 cubic inches. So 320 will equal our volume here. Okay, and then we have to solve that. So if we get it equal to 0, if we take 32 and we subtract 320, we get negative 288. Okay. You can solve this different ways. Quadratic formula, completing the square, Desmos, a lot of different ways you could do it. Let's say we use graphing. Okay, so go ahead and put that into Desmos and see what the graph looks like. Okay, when you graph that in Desmos, you'll get this, negative 6 and 12, or if you use quadratic formula or whatever you're going to use. Okay, so this is a little tricky. We have to know what the bottom of the box is going to be. Okay, so this is what we just solved for is our x. You could probably even factor this as well. That factoring would work out. Now, can this x here be equal to a negative number? Nope, so we can rule that out. So if this x is 12, that, I know this is 24, but it's not asking us that. It's asking us what are the dimensions of the bottom of the box. So what is this dimension right here, right? So if this dimension is 12, minus 2 and minus 2, this distance would be 8 by, okay, so this whole thing is 2 times 12, so it would be 24, minus 2 minus 2, 8 by 20. Okay, that was a little tricky there because after you solve x, you kind of have to think through what the bottom of the box is going to be. Okay, and E, determine graphically, to the nearest tenth of an inch, the value of x if the box is to have a volume between 400 and 500. Okay, so once again, let's graph it on Desmos. Okay, so if you just take this equation right here and graph it on Desmos, not the one we used here where we set it equal to something, we get a graph that looks something like this, something like that, I'm not sure exactly. But we want to know what are the x values where it's between 400 and 500. Okay, so by looking over at Desmos, you want to look for the x values for where it's 400 and 500. And this one is somewhere around 13, and this one here is about 14.2. So between 13 and 14.2 inches. Okay, next problem, 27. Okay, we got this picture for us. Okay, the boat is 12 feet from the dock, and the rope is 3 feet more than twice the height of the dock. Find the height of the dock. Okay, so we're going to use that a squared plus b squared. Whoops, that's not right. My b has to be this, right? A and b equals my c squared, which is the hypotenuse. Okay, so I know that h squared plus 144. And if I multiply this out, that'd be 2h squared. Right, multiply it by itself. Be plus 6 would be plus 12h, and plus 9. Okay, so to solve this, let's solve the quadratic. I'm going to bring it all over this way, so I'm going to subtract this h squared over. So 2h squared minus an h squared is 1, plus 12h, and if I subtract that over, I have 9 minus 144, which gives you negative 135. Okay, you can factor, you can do whatever there. I think factoring will work. Or graph it as well, you could do. Actually, I just made it. You hopefully noticed my mistake there. 2 times 2 is 4h squared, right? So when I subtract that over, I have 3h squared. Okay. So it can factor. Let's see, 135. Okay, so that would be 27 minus 15. Yep, that works. Okay, so I get x is equal to negative 27 over 3. Oh, I should have factored out a 3 first, shouldn't I? Greatest common factor. Anyway, equals negative 9, and x equals 5. Now, can this distance, can this height be negative 9? Nope. So I know that it has to be 5. Okay, number 30. Okay, number 30 here. You can see it, yep. So dimensions of a solar panel, it's this one right here. We know the width is 26 inches, as shown in the figure below. To get a proper inclination for her climate, she needs a right triangle support with one leg twice as long as the other. Okay, so she needs this leg and that leg to be. So we're basically looking at that triangle there. We know that this is 26. We need one leg, and the other leg twice as long as the other leg. Okay. What should the dimensions should the frame have? Okay. So I know that a squared plus b squared has to equal c squared. So bx squared plus 4 squared, which is a total of 5x squareds, equals 26 squared, which is 676. Divide by 5. X squared is equal to 135.2. And take the square root. Gives me plus or minus 11.63. Okay, now I can't really use the negative. So it's going to have to be 11.63 by, okay, that's my x, my other distance has to be times 2. 11.63 times 2 gives me 23.26. Okay, we have a picture with a frame that is 2 inches wide all the way around. The picture inside the frame is 4 inches longer than it is wide. Okay, so this is the picture on the inside. is 4 inches longer than it is wide. So if this is x, this is going to be x plus 4. The area of the picture is 30, okay? So the inside dimension, we have those. We know that that area is equal to 320. Okay, so we have to solve this here. So I have x squared plus 4x. Let's use completing the square here. So half of this is 2, 2 squared is 4, so plus 4 and plus 4. You can use what other method you want. And if I take the square root of 324 gives me 18. So know that x plus 2 is equal to plus or minus 18. And subtract the 2 over would be negative 2 plus or minus 18. Negative 2 minus 18 would be negative 20, which we know won't work for a distance. Negative 2 plus 18 would be 16. Okay, so I know this is 16 by 20 basically. But that's not what it's asking here, right? It's asking you what are the outside dimensions of the picture frame. So if this is 16 plus 2 inches and 2 inches, it'd be 20. And if it's 20 and 2 inches and 2 inches, it'd be 24. So the outside picture frame is 20 by 24. 37. Okay, we got our leaping frog here. Okay, so this is kind of a picture. It leaps from the stump and it jumps out here, okay, to this spot right here, and it gave you this equation for it. So we have h of x is equal to negative 0.5x squared plus 1.25x plus 3. Okay, how high was the frog when the horizontal distance from the base was 2? Okay, so if we want to know where the horizontal distance, where our x is a 2, okay, so where an x is a 2, I want to know where the y is, so I can just plug that in there. Okay, so h of 2, negative 0.5 times 2 squared plus 1.25 times 2 plus 3, and that gives me 3.5 feet. So it started at 3 feet in the air, right, on the stump, jumped up, and it, right there at 2 would be 2 feet away. It was 3.5 feet in the air. Okay, part B. What was the horizontal distance from the base when it was at 3.25 feet? So I want to know where this was at 3.25. I want to know how far out it was. Okay, so it's probably a point here and a point there, right? So use Desmos for this. Okay, so put this in there and see where this y is equal to 3.25. My x would equal 0.2, so pretty soon after he took off. And then also again out here at 2.3 feet. C, what is the horizontal distance from the base of the stump did it reach its highest point? So we want to know the vertex once again, so negative b over 2 times a. Okay, and it asks for the horizontal distance, which is our x variable, right? And that comes up to be 1.25. So at 1.25, it reaches its maximum. Maximum height reached, okay, maximum height would be where this x is, so that would be negative 0.5 times 1.25 squared plus 1.25 times 1.25 plus 3, and it gives you approximately about 3.78. Use Desmos to get a visual of that and play with that a bit. Last one was number 42. Okay, so this is one where you're going to use Desmos and type in the table. Okay, so this number of Walmart employees in millions. Okay, this is since 1987. So this is year 1987, and then 5 years later would be 1992. Okay. Okay, and 10 years later would be 97, etc. Okay, so part A, evaluate E of 15. Okay, so you just plug in the 15 to the equation. So you kind of need the model there. Oh, well, actually, E of 15 is, right, 15 would be 1.4. Okay, in 2015. So 15 years after that would be 2002. Okay. Part B, now you want to use the equation. So put these into Desmos and get your equation there. Y1 tilde mx, no, a x squared, x1 squared, plus b x1 plus c. And it gives you an equation roughly about y is equal to 0.0047 x squared plus 0.0055x plus 0.205. Okay, you could round that a little differently. It's okay. Okay, when is it going to reach 3 million? So I want to know where this is equal to 3. Okay, so you can use, I would take this 3 and subtract it over, and then use Desmos, or probably not any other method except the quadratic formula, but it would be roughly about, it'd be 24. So if you think about 87 plus 24 years gives you about 2011. So in about 2011, they reached 3 million employees. Okay, if you have questions about that homework, feel free to give me an email, and we'll definitely talk about it in class the next day as well.